Good morning, good evening, and my name is Paul Voutier from Ambit Robotics. And firstly, I want to say thank you to FIRA for having me this evening. It's a real pleasure to be here. And I know that FIRA has traditionally focused on the European market, the American market, and I hope that this presentation will give you a sense of what's happening in agricultural robotics in Asia, where I think the needs are very different. And the opportunities are very different. All right, so by way of an introduction to myself, I've been working in agriculture in Asia for the last 10 years. Been living in both Australia and Singapore and in Sri Lanka. And I've been working as a consultant to large agribusinesses, NGOs, and donors, really around this question of the small farms that we have here in Asia and how we can reach those small farmers with new technologies. It might surprise you that there are 73 million small family farms in Southeast Asia. There are another 100 million in India, and a similar number again in China. So the region is characterized by very, very small farms, often around 1 hectare, in very concentrated areas like the region around Jakarta, sometimes as small as 1 acre. And in fact, these small family farms, while small, are very significant to the regional food security in Southeast Asia. So about 70% of our foods from this region are grown on small family farms. And I've written pretty extensively around the challenges that are specific to using technology on small family farms, and a couple of the reports I've written are there. But more recently, I really dedicated myself to agricultural robotics, and particularly small robots for small farms. And that's very much the vision of Ambit Robotics, is building a technology that's appropriate and scalable for Southeast Asia and Asia more broadly around these very small family farms. The challenge that we are looking at addressing with Ambit Robotics is the challenge of crop spraying on small farms. And at the moment, this picture typifies how we would be normally spraying in Asia. People will walk up and down the crop rows with a backpack. Sometimes it'll be a powered backpack like you see here. Sometimes they'll be pumping by hand to pump the crop protection onto their products, but it's a very slow task. First of all, it's very dangerous. So as you can see in this picture, the users are exposed to chemicals all day. There's very little use of protective equipment. It's also very expensive. So in an indoor shade house environment, we're looking at 19 hours per hectare. Out in an open field, we might be looking at 10 or 12 hours per hectare. So that, even at very low labor rates in Asia, that cost really adds up. And we estimate that farmers across Asia are spending about $20 billion a year on labor to spray from a backpack. So it's not a small market, and it certainly adds up. You get very poor accuracy using this approach, and you do have some rows that get missed in the most extreme, but you certainly have plants that are missed and parts of plants that are missed in the way that things are sprayed at the moment. And as you can see from this image, it's just not environmentally or socially sustainable to be continuing to spray in this way. But it's not just a challenge for the spray teams that go from farm to spray. It's a real problem for the food brands in Asia who are buying foods from these farmers. You get residue, you get a high cost of things like potatoes because of this high cost of labor. It's a real challenge for seed companies when they want to produce quality seeds. They don't get the crop protection they should be getting out of their products. And it's a real challenge for chemical companies because they develop these fantastic chemical products, but the way that things are sprayed at the moment, the farmers just aren't getting value from the chemical portfolios that are being developed by the leading research-based crop protection companies. Our solution is a very straightforward and small, low-cost robot, which goes up and down the rows, spraying them very accurately, very safely. It's all driven by battery. All very compact and I think very appropriate to be put on the back of a motorbike, taken from farm to farm in the context in which we find ourselves, and providing a much more accurate, much faster way of spraying for our region. In terms of how it works, the robot is shown there on the left in a strawberry farm in a pretty cool, typical arm configuration. The arm that you see there on the top is very adjustable. You can set it up however you like. You can spray melons or tomatoes that are trellised to a quite high height, or you can spray a low crop here like a strawberry that you see here. The robot's super simple to use. You place it down at the end of the first row. It navigates in automated fashion to the end of the row, turns around in an automated fashion and returns, and then the user can refill it at the end of the row. So the user just stands there and waits for it to come back and refills it. It's got a whole suite of sensors on board that control the robot to the end of the row, sense the end of the row and return. But it is a very simple piece of technology. It's all controlled from an Android app. So the farmer just downloads, or the user downloads the Android app, and they're off and away. In terms of where we see this robot being rolled out, it isn't a technology for farmers. We wouldn't expect to be selling or leasing it directly to farmers, because the spray contractors, the people that are spraying at the moment, they go from farm to farm, and that's the way they run their business. And we want them to do the same thing with the robot, but they can earn a lot more money. So they would be earning about $500 US at the moment, because it just takes so long to spray each farm. And we can get them up to about $1,500 US. So a very significant increase in income that comes from the much higher speed that the robot operates. We intend to begin leasing the robots for $200 a month in the near future. And the production cost is very low. In terms of where we see these robots going, there is a very significant market in India, Thailand, and Vietnam, and Indonesia for these robots. These are countries where you get our target crops: chili, tomato, potato. These are crops that we can address very efficiently, and particularly the vegetable growing regions around the capital cities of these countries, where you have farmers that are using external labor to spray, and I think would really benefit from this robot. In terms of our progress to date, we are conducting trials with one of the world's larger chemical companies, seed companies, and food companies. We've got trials ongoing in India, Thailand, and Indonesia, and the robot is being used on a whole range of different robot crops, and we continue to conduct trials in Australia, where I'm based also. In terms of where Ambit Robotics is today, we believe, the first robot to market for spraying in Southeast Asia. We've got some great partnerships with food brands and chemical companies, and we'd certainly be keen to talk to anybody who's here today for the FIRA event about partnerships to roll out these robots. We are specifically looking at indoor environments. Seed vegetable production in shade houses is a real target at the moment, but we'll obviously talk to a wide variety of different businesses about rolling out this robot. We do get a really compelling payback period on the robot, and as I said, this is a solution that is out there, it's in the field and operating. So very keen to talk partnerships and next steps with anybody that's interested. If you would like to get in touch with us at Ambit Robotics, the website is there, my email address is there, and I will be around the FIRA event for the rest of the day, so you can connect with me there. I won't take too much more of your time. I'm keen to get on to questions from you. If there's anything else that you wanted to know or clarify about the robot, please add them to the Q&A, and I will attempt to address them now. Otherwise, as I say, connect via LinkedIn, send me an email, go to the website, and you can certainly find out more. So I'll begin addressing the questions that are here in the chat, and please continue to add more. The first question is about the market. Do you intend to develop your business in Europe? That's an interesting question. Certainly the robot was designed from the ground up for the Asian market, and we are particularly focused on small farms. We are getting some interest from elsewhere in the world, and we would be keen to talk to businesses in Europe. I think the thing to remember if you're talking about a developed market like Europe is that if farmers are already using tractors to spray, if they have other automated spraying, I don't see a robot of this scale competing. I think it's really appropriate where you are using those backpack sprayers, where you've got those really long spray times. I think that's where we can really add value. So if there are pockets around Europe where farmers are just not getting the efficiency out of their spraying, they're not getting the accuracy they need, absolutely, we'd be keen. The next question here is, what is the biggest technical challenge you have in deploying these robots reliably at a large scale? I think there's a few technical challenges that, that are relevant. I think probably serviceability is a real challenge for us. So when you place a robot into a remote part of rural Asia, there's, motors do fail, pumps fail, and I think there needs to be some system in place to replace those. And that's something that we're very conscious of. And we want to concentrate the rollout of our robots into very specific geographic locations where we can provide that after-sales service. I think that's probably the most significant. I think most other elements of the robot are quite robust, waterproof, designed for longevity. There's not a lot of complexity in the unit. I think it's something that we will find stands the test of time in this context. The next question here from Larry Jacobs regards to how many litres does it hold, and does it need to be row loaded at the end of each row? So the robot that you see there in the images will hold 8 litres of chemical. We can design that, we can manufacture the robot up to about 16 litres. That depends on the row gap. So if you have a narrow row gap, you're at about 8 litres. If you've got a wide row gap, then you can go up to 16 litres. The thing is that the next question relates to, is it reloaded at the end of each row? That depends on how many litres you want to use. If you are at the lower end of the spectrum, so if you're around 200 to 400 litres per hectare, then you will get 4 rows rather than 2 from each tank. If you're up around 600 or 800 litres per hectare, then you will just get 2 rows, and then you have to refill. So, and that's just a trade-off with the area that's available. If you want to run a robot between the crop row, it's got to fit, and so the size of that tank is tailored depending on the gap that is present between the plants for it to operate. If I don't cover anything in my answers that you were really looking for, just add another question in, and I'll attempt to clarify anything that's not clear. Next question is, the estimated, how did you get to the estimated cost to produce of $400? Does your product contain any safety or autonomy features? So the cost to produce the robot is the parts that we use plus the labour. It does retail at more than that, but that is the cost ex-factory gate. What does your product contain any features or any safety or autonomy features? In terms of safety, we think in terms of exposure to chemicals, there's a strong argument for the robot. So if you're standing at the end of the row and the robot starts spraying as it enters the row, you are certainly getting a lot less exposure to chemicals than if you're spraying from a backpack, which is the alternative. In terms of other safety features, if you want to pause or stop the robot, then you can from the Android app. You're in control of the robot throughout the use of the robot. In terms of autonomy, it is autonomous from the start of that row. So once you hit go, it will automatically move down the row. It's able to detect where it is in the row. It is able to detect the end of the row, turn about around and return. And it will actually even enter the next row for it. So you don't actually have to touch the robot. It will, it is fully automated. It is fully automated up and back. The only thing you do need to do is refill, and the Android app tells you to do that. It says refill on the screen, and you just refill the robot. You can do that from a backpack or a hose or a pump from a tank. What's the lifetime of your robot? We would expect, certainly any economic modeling we do on the robot is based on a 24-month lifetime. After that point, I think there's certainly elements of the robot that would still be in good condition, but others that need to be replaced. So the economic analysis is based on 2 years. Would you see a pump being replaced or a drive motor being replaced in that 2 years? Yeah, possibly after a year or so, you'll be possibly replacing a pump or a motor. And you're looking at about $20, $30 to replace those motors. So not a huge expense, it's not difficult to do, and it's designed to be field serviceable. But yeah, the answer to the question is we'd expect about 2 years. Next question, very good one about battery life. One of the real advantages of a ground-based robot over a drone is battery usage is much lower. That's going to lower your overall cost of usage significantly. We would expect to be at full spray, full speed for an hour per battery. That will give you about a hectare, depending on how it's being used. Maybe a little less than a hectare, depending on the quantity that you're spraying. Batteries themselves are about $30 or $40. So a user could have 3 or 4 or 5 batteries on a go at a time. You could potentially have a solar panel that you carry with you to charge the batteries you're not using, or you could simply set up for the day with all the batteries that you need and charge them at home. They're only drawing a couple of amps at 12 volts to charge, so it's something that you can charge very easy from your household or from your vehicle. One of the things I didn't say earlier is that I think one of the really important design priorities for us is to get this onto the back of a motorbike rather than into a car. And I think that just cuts down the cost of operating this robot significantly when you can take it around on the back of a motorbike. So we are looking for a unit that fits together with the batteries on the back of a motorbike. The next question and last question, unless there are any more, and please do add more if you have them, is why do they spray from hand and not spray from a boom? Why they spray by hand and not spray from a boom spray generally? So why is the hand spraying done at the moment? Good question. So there is a few reasons. So one is tractors are just not economic. So there are tractors used for ground preparation or ploughing, tilling in Asia. That's relatively common, but we don't see tractor-based spraying. And that's for a few reasons. One is it's just not economic to move a tractor around from farm to farm for the purposes of spraying. It's quicker and easier. It's cheaper to do it by hand because labor rates are quite low. And also the farms are just not configured for tractors. So they can plow with a tractor, but once the crop emerges, there isn't space. They pack their planting in pretty tightly, have good densities, and that allows a human to travel obviously between the rows rather than a tractor. So that's why they're sprayed by hand. There has been some attempt at sort of hand-based boom kind of arrangements, but it's not something that's really taken off. So yeah, that's the reason for the hand-based spraying that we see across the region. Very good. Look, I've got a 2-minute warning here, so if there are any more questions, please do contact me by LinkedIn, via email or other methods. And as I say, I will be around the FIRA event for the rest of the day and in those networking rooms. So please feel free to reach out to me on the platform. Thank you very much for your interest in what I hope is quite an intriguing and interesting take on robotics for very specific to our region and our farm size. So thank you very much for attending. Bye for now.